Alright, hi guys. The last time we talked about section 7.1, so just a little bit review on 7.1. Last time when we talked about the three important concepts, we talked about how to find the arc length, how to find the area of a sector, and most importantly, we talked about how to convert from radians to degrees and vice versa. Okay, so the relationship between radians and degrees, it can be like interpreted by the equation 180 degrees equivalent to pi radians. Okay, and again, if you like need to convert from degrees to radian or vice versa, you can use that equation and cross multiplication to solve or to convert into whatever like unit system that you want to. Okay, the second concept is how to find the arc length. I personally, I remember the formula S equals to R theta. Or if you don't want that formula, you can remember the original formula, which is theta equals to S divided by R. In the two formulas to find the arc length above, you must have the angle theta in radians. No other way, no exception. Okay. If you use radian, if you don't use radian, and if you use degrees for theta, you're gonna get the wrong arc length. You're gonna get the wrong answer for arc length. Okay, and then the last concept that we learned from 7.1 is about how to find the area of a sector of a circle. There are also two formulas for it. The first formula is A equals to 1/2 R squared theta. This formula is helpful only when you have the angle theta, and again, you have to use theta in radians, not in degrees. Okay, and the second formula is area A equals to 1/2 R times S. S in here is the arc length. This formula is only helpful when you have the arc length. Okay. All right. Let's talk about 7.2, right triangle, trigonometry. So usually before we get to the first objective of the day, let's review some old concept. Let me use a pen in here. Let me change to red. Come on. Alright, so the first concept, a triangle in which one angle is right angle or 90 degrees is called a right triangle. This is what we learned from geometry. Okay, or if you want, you can like see this picture right here. This one has a right angle right here. Did a good job of drawing like that angle. So, okay, this is the right angle. Okay, and then that's why the name for the triangle will be right triangle, because that's one right angle. Okay, and then in the right triangle, we have a very important theorem, is Pythagorean theorem, or in this class for shortcut, I'm gonna call it PT. It tells us that a squared plus b squared equal to c squared, this formula right here in the box. So as we can see in here, C in here is a hypotenuse, is the longest side among the three in the triangle. And A and B in here, they are all legs. So this one in here, just for this scenario, just for this picture, B is the shorter leg and A in here is the longer leg. But it really doesn't matter like which one you refer to it. You can call this one A and this one B. That works as well. Okay, it really doesn't matter. But C, there's only one C. The C has to be fixed. Okay, like the C is the longest side, no negotiation. Okay. And the next concept is acute angle. So what does it mean by acute angle, right? Like we know that a right angle is the angle that has a measure of 90 degrees. Acute angle is the angle that has a measure less than 90 degrees. But of course, we're talking about measures, so of course the angle has to be positive, right? Now some of you guys may ask me, well, in 7.1 we talk about negative angles, right? Like we had negative 62 degrees or negative 90 degrees. Now what does that mean? Well, the negative in there is only for the rotation, okay? If you have a positive angle, it means that you have that angle going counterclockwise. If you have a negative angle, it means that you have that angle going clockwise, okay? And remember, an angle has two parts in there. The first part is about the rotation. It decides whether your angle is positive or negative. But the second part is about the measure, and the measure in here is only positive. We're not going to have any negative measure, okay? And if you don't remember what quadrant mean, it's talking about like when we have the x and y axis like this, where x is the horizontal axis and y is the vertical axis. And in here we're going to have like 4 spaces, or we refer to it by quadrant. We number them like quadrant 1, 2, 3, and 4 by going counterclockwise this way, okay? So if you have anything less than 90, it must be in quadrant 1 right here, okay? If you have something bigger than 90, it would be like in quadrant 2, maybe, if it's less than 180. For example, if you have like 100 degrees or like 150 degrees, they are in quadrant 2, and so on and so forth with quadrant 3 and quadrant 4, okay? Now, let me introduce you guys something about similar triangle. Just imagine you start with a right triangle like this, okay? And you decided you don't want to have just one triangle because it looks lonely to be there alone, right? So you want to zoom it in or you want to zoom it out, doesn't matter which way you think about it. But let's say you have a red triangle and you zoom it out. So then you have a purple triangle, you have a smaller triangle right there, right? As you can see, they are like the purple triangle is the mini version of the red triangle. If you don't trust me, you can measure them, but I can assure you guys that the 3 angles in the 2 triangles, they are the same, like correspondingly. Like this angle in here equals to this angle in here. Well, this angle is like the same because they like each other anyways because of the position, and this angle in here is the same as this angle in here because they both are right angles. Okay, so let's me get that out of the picture. Okay, enough talking about angles. Let's talk about ratios, right? We know that each triangle will have like 3 sides because it's triangle, try in here for 3. So we have length ABC for triangle, the red triangle, and we have length A prime, B prime, C prime for the purple triangle, right? In here, you notice there's something really interesting about the ratio between the purple and the red triangle. We have B over C equivalent to B prime over C prime. And if you want, you can fill out the rest of them like this. And this is actually a cool fact. This is actually where we come up with a definition for the 6th trigonometric function. This is where we have sine, cosine, tangent, cosecant, secant, and finally cotangent. Okay, so let's talk about the real definition of all 6 of them. Okay, so the 6 ratios of a right triangle, all 6 of them, we call them trigonometric functions of acute triangles. And if you don't remember what acute triangles are, let me remind you guys. Acute angles are the angles that has a measure less than 90. Okay, so let me put it down right here. This is less than 90 degrees. Okay, and if you remember the ABC system that we had in the last slide, these, oh here, let me pull, okay, there. Okay, like this ABC system in there, they are all side lengths, right? So they must be positive, okay? We cannot have like negative side lengths, okay? So now let's define all 6 of them. Okay, let me scroll this one up a little bit. Okay, so sine, we have sine equals to opposite, or O, divided by hypotenuse. Okay, and then cosine is adjacent divided by hypotenuse. Tangent is opposite divided by adjacent. Now, if you wonder how I can remember all of them so quickly, this is actually a trick to remember this, okay? I'm pretty sure some of you guys might have heard of this trick. We call it SOHCAHTOA. SOHCAHTOA. Why is that so? So in here is because of this. This is so. Chi in here because of cosine. And TOA is because of tangent. Okay? I know that in a table or even in the book they show you the definition by showing the value of ABC. I will not recommend this system at all because like I said before, C there's only one hypotenuse in the triangle, but B and A they could be like misinterpreted. Why? Because A and B they don't like really matter for the legs because one could be longer than the other, so that's why A and B they have like different position. But when it comes to opposite and adjacent, they mean like specific things. Okay, so if I have to recommend you something to remember, make sure you remember the system SOHCAHTOA. Okay, so that's like a little bit of memory. Okay, now let's talk about cosecant, secant, and cotangent. These three, these are not like as common mentioned as the first three, but they're still important in the sense that they flip the first three trigonometric functions that we just mentioned. So cosecant, it's matching up with sine, so it would be hypotenuse divided by opposite. Cosine is matching up with secant, so that is hypotenuse divided by adjacent. And lastly, we have tangent and cotangent. To me, the last pair, tangent and cotangent, are like the easiest one to remember because of the name, right? Like tangent and cotangent. Just by the pronunciation, you will know right away that they're pairing up with each other. So because tangent is opposite divided by adjacent, cotangent should be adjacent divided by opposite. Okay, so now a quick trick to remember which one pairs with which one. I'll tell you guys, one C function pairs with a non-C function. Now, what do I mean by that? First of all, we know that tangent pairs up with cotangent, right? Just by the name of them. And if you notice, cotangent has a C, tangent doesn't start with a C, right? That's what I mean by a C function pairs with a non-C function. And in here, we have a C function again, cosecant. We have two options left, either sine or cosine. Cosine has a C already, so cosecant must be paired up with sine, right? And again, cosine has a C in there already, so it must be paired up with secant. So that's all my trick to remember which one to like flip. If you don't remember like all six of the formulas in here, I really recommend you guys remember just the first three SOHCAHTOA and then remember which one pairs with which one. After that, you're good to go. Okay, so now let's talk about the very first example of today. Find the value of the 6 trigonometric functions of the angle theta in the following triangles. So we are given a right triangle right here. We know that this is theta. This is the angle that we want to. Okay, some of you guys will ask me like, why do we know that the angle theta is right there? Well, first of all, it's given, right? They could have picked the angle theta to be in here, but they don't want to. So theta is picked by like whoever gives you the problem, okay? It's not like why is there, not the other way around. It's just a problem, so don't be confused about the position of theta, okay? But since this problem gives you theta right like at the top, let me get rid of the arrow, the orange arrow that I just draw. Okay, now let's define hypotenuse, adjacent, and opposite in this triangle right here. Opposite to theta, let's draw like a arrow to show which side is opposite to theta. If you draw this arrow like this, you will see right away that this side right here, it is opposite to theta, okay? And then that's the easiest thing to like know, like personally. So now we have adjacent and we have hypotenuse. Just eyeball it out. Hypotenuse has to be the longest side, right? And usually, I mean, like by definition, hypotenuse is the side that is opposite to the right angle. So here's the right angle, and we have hypotenuse right here. Okay, sorry for the color. I'm not going to use yellow again. This looks like a little bit annoying. Here, let me change it to, I don't know, blue maybe. So again, here's a right angle, and across it we have hypotenuse. Okay, we have one more side. Let's do it in purple. This side right here, we call it adjacent. Okay, what does it mean by adjacent in English? Adjacent in English, it means next to, nearby. If you notice the purple sign here, it lies right next to theta. And some of you guys may ask me, like, there's two sides that lies next to theta, the purple side and the blue side. How do I know which one is adjacent? Well, I'm gonna tell you, there's two sides lying next to theta, but only one of them could be adjacent, because the other one, it must be like hypotenuse, right? And then hypotenuse usually is easier to find first, because like the purple sign here is right next to the right angle, so you know for a fact that the purple sign here cannot be the hypotenuse. Okay, so that's enough of like identify which one is hypotenuse, adjacent, and opposite. So now let's get to the working here. We have SOHCAHTOA. Let's write down here really quick just to remind us. SOHCAHTOA. Okay, sine. We have opposite divided by hypotenuse. Opposite to it, we have 2. Hypotenuse in here, we don't know. So let's get back to here. That's why I leave like a space in here for us to fill out. By PT, Pythagorean theorem. Earlier, we have a system of a squared plus b squared equal to c squared. We all know that c squared is a hypotenuse, right? So now, let me give you something else, because I told you not to use a system of like ABC, right? So let's do adjacent squared plus opposite squared equals to hypotenuse squared. They mean the same thing as the ABC system. Okay, so don't get confused by this. We have adjacent in here is square root of 3. Square root of 3 squared, it is 3. We have opposite square, which is 2 squared, that is 4. And then this is equal to hypotenuse squared. So hypotenuse in here, it has to be 7. But wait, what do we do with the square root, right? Like, I mean, with the square, 7 here is only the square, right? It's not the square root or anything. So if we want to find h, we have to take the square root of it, like this. So now we know the hypotenuse is square root of 7. Okay, I really want to stretch on this one. Stress on this one, because on the quizzes, on the exams, a lot of people make this same mistake, and I really don't want you guys to lose any point on this one. So just be careful with this one. When you add up the number, that's not the final stage. Okay, the last step is to take the square root of whatever you had from here, from the addition, like whatever you add up in there to get you. Make sure you take the square root. Okay, if you don't take the square root and just assume that's your answer, you're wrong. Okay. All right, let's get back to SOHCAHTOA. So sine here is opposite divided by hypotenuse. We know that opposite is 2. Hypotenuse here is square root of 7. We just found it. All right, so this one is an okay answer to me, but I would love it if you guys can rationalize it on the test, homework, on whatever you turn into me. Because personally, I don't like it when I see a rational or like a square root on the bottom or on the denominator of the fraction. It looks kind of like irritating. So what I would do is that I multiply the top and bottom by square root of 7. Excuse my bad writing, I'm running out of space. That's why I'm trying to write small, but then it looks kind of like ugly. Okay, so from the top part, we're going to have 2 times square root of 7. Okay. A lot of like mistakes from this one, it could be like, why don't we multiply the 2 and the 7? Well, the 2 doesn't have a square root, right? And the 7 is inside the square root. So they are like 2 different things. We can put them together, but we cannot like multiply them. Okay, for example, okay, let me change the color of this one really quick. If you have like 2 square root of 7 times 3 square root of 2, then outside times outside and inside times inside, you're going to have 6 square root of 14. Okay, if you have something like 2 times 3 square root of, I don't know, like 5, this 2 in here, it doesn't even have any square root, right? So you can think of it like it's like outside the square root. If it's inside the square root, you must see the square root, right? Else is outside of the square root. So we're gonna do 6 square root of 5 in here. Okay, because of the 2 times 3, that's why we got the 6. And the 5 in here is just a loner because like it's the only square that we have among the two numbers in here. Okay, and then let's get back to our answer in here. For the bottom, we're gonna have square root of 7 times square root of 7. There's 2 ways to think about it. If you want to multiply 7 and 7, you get 49, and then square root of 49 will get you back 7. Another way to think about it is that when you like take the square root of a number square, like of the number that looks like a jotter, they cancel out. What do I mean? I mean like if you do square root of 7 square, the square root would cancel out with the square, and then that gets you 7. So either way, you can think of this problem either way. Okay, let me change the color of this one for cosi because I think it's gonna look like messy in here. For cosi, we have adjacent divided by hypotenuse. Adjacent in here is square root of 3. Hypotenuse in here is square root of 7. Again, we multiply the top and bottom by square root of 7. That gets me square root of 21 for 3 times 7, and then 7. Okay, and then for tangent, let's use, I don't know, like green. Tangent, TOA, we have opposite divided by adjacent. So let me do it in here. Opposite in here is 2 divided by adjacent, which is square root of 3. Again, we're going to multiply the top and bottom by square root of 3, and we're going to get 2 square root of 3 divided by 3. Okay, I do it so fast because I've been like, first of all, I'm a math major. I've been doing this for like so long. That's why I'm doing it fast. But don't worry if like you have a problem with this at the beginning, because like the more practice, you will get faster, okay? So don't worry too much about this. But make sure you get enough practice before next week, because we're going to have quiz 1 next week. And this will be seen on quiz 1. Okay? For cosecant, it's the flip of sign. So you have 2 options. You can do 7 divided by 2 square root of 7 if you want to flip this number. But then, again, you're going to see like rational on the bottom. You're going to see the square root of 7 on the bottom, which is like kind of like irritating. That's why I'm not going to recommend like flipping the final answer in here. Other than that, to figure out cosecant, I will flip the very first thing that you had. Let me highlight this thing in red. This one in here. I'm going to flip that one to get square root of 7 divided by 2. And this is cool because we don't have any square root on the bottom. So this is the final answer for cosecant. Okay, and then let me switch your ping to figure out secant. Again, you have 2 options. You can flip this number or this number, but personally, I'm gonna flip the very first thing, because think about it. If you flip the second like answer, you're gonna get 7 divided by square root of 21, and 21 is a big number. You don't want to rationalize the big number. But if you flip like square root of 7 divided by square root of 3, this one is like small, and it's like, to me, it's more doable compared to square root of 21, right? So again, we're going to multiply the top and bottom by square root of 3, and then similarly, we're going to get square root of 21 divided by 3. Okay, last one, cotangent. I'm running out of space, so let me just write in here. Okay, again, you have 2 options of flipping either this one or that one, but I'm going to be smart about this one. I want to save the time. So I'm going to flip the very first answer to get square root of 3 divided by 2. All done. So we have 6 answers in here. And then here is your turn. Try this one, okay? I put a green star in here. All right. Oh, one more thing. Here's kind of like the note, the footnote in here. We will use a setup for of like the 6 trig function in the quizzes and exam. There's a purpose of this setup, actually, if you guys notice. Let me erase some of this first so I have more space. Alright, here, now it looks better. Okay, this setup in here of the 6 function, I want you guys to figure out SOHCAHTOA first. That's why I do sine, cosine, and tangent, because they're just, by definition, SOHCAHTOA, it's easier for us to do. This column in here is the flip of the very first column, and they look sideways to each other, right? So I purposely have this set up to help you guys on the test and exam, so that it's easier for you to like figure out the answers. Okay, hope that helps. All right, the second objective, use the fundamental identities. This one is harder a little bit, and if you're asking why I put these formulas in the box, that is because these formulas are really important. You're gonna have to use these in the quizzes and the exams. So make sure you put them, like print it out, cut them up, put on the wall, whatever you want to do with it. Make sure you like have it somewhere before you have the test. Okay. All right. By the relationships between sine, cosine, tangent, cosecant, secant, and cotangent, we also have the fundamental identities among the 6 trigonometric functions of acute angles. Alright, so I show you guys the flip of each other. Reciprocal is like the name, like the fancy word for flip. Okay, like just in case you don't know what reciprocal is. And just a heads up, in the test, I'm not going to ask you guys to write reciprocal or any like long, lengthy word. But if you misspell something like that, like English-wise, I'm not going to mark you up, okay? Because this is a math class. It's not English class, okay? So the tip to remember this is like, remember that one C function will pair up with one non-C function. And tangent and cotangent, they just pair up by the nature of them, right? Like by their names, you know for a fact that tangent has to go with cotangent and vice versa. Okay, quotient identity, the next one. Okay, my trick to remember tangent and cotangent formula for this one is that I introduce you guys SOHCAHTOA. So remember the order. So comes first, and then ka, and then toa comes last, right? It means that tangent in here equals to sine divided by cosine. That's my tip. Okay, for cosine equals to cosine divided by sine, well, you don't have to remember this. You just have to remember that cosine is the flip of tangent. That's why you just like flip them. That's enough, right? You don't have to remember like cosine equals to cotangent equals to cosine divided by sine. To me, that's not like important. Like you can like embrace it in your brain. That's cool. If not, that's fine. Lastly, we have Pythagorean identities. Okay, a tips in here to remember this is that whenever we talk about Pythagorean, it means square. What do I mean by square? If you look among the 3 formulas in here, they all have something squares, right? They all have like the exponent of 2 in them. Why is that so? Because like originally from the Pythagorean theorem, we know that a squared plus b squared equals to c squared, right? Like all 3 a, b, c has a square. So if you wonder why the 1 doesn't have a square, it's because 1 square is 1. We're not going to write 1 square because we know that 1 square is 1 times 1, which is 1. So we rather use 1 rather than 1 square. Okay? I don't have any tips to remember these, to be honest. If you want to prove them, you can prove them by using the definitions, SOHCAHTOA. This is not a proof class, so I'm not going to ask you guys to do so. If you want, you're welcome to do it. How to remember them, I don't know, to be honest. For me, they just come really naturally. I just remember them. Sine and cosine, because of the name, they come together in the Pythagorean. For tangent and cotangent, unfortunately, they like separate, even they like by names should be together. So I don't know, it's like confuse you guys even more for the tips to remember this. But again, like honestly, I don't have any tips to remember the last 3 formulas. But since this one is like online class, I highly recommend you guys like writing these like table down and have them memorized or just like in front of you in case you need to pull out any of the formulas in here. for the test, quiz, or anything important, even for homework. Okay. All right, so now we have sine, cosine given. We have to find the remaining 4 trigonometric functions, meaning cosecant, tangent, secant, and cotangent. There's a typo on this one. It's supposed to be secant of theta. Okay, so I told you about the flip, like the reciprocal of each other already. So if I know sine, automatically I will know cosecant. So sine is 1/3. Cosecant would be 3/1, which is 3. Okay, so some of you guys might ask me, like in the test, if I just put like 3 divided by 1, do I get marked out? Yes, I will mark you off from this one, okay? I'm just gonna take out like 1 or 2 like partial credit for this one. Why? Because we can simplify that, all right? So just imagine if you have like 1 plus 1, you're not gonna give me 1 plus 1, you wanna give me 2, okay? So keep that in mind. You want to simplify all the answers, okay? Don't leave it like hanging just there, okay? And because we have cosine here, so we will know the reciprocal of it, which is secant, and we flip it to get 3 divided by 2 square root of 2. And again, we have the radical on the bottom. That looks ugly, so let's multiply it by square root of 2 divided by 2. Now, some of you guys may ask me, why don't we multiply the top and bottom by 2 square root of 2? I'm going to tell you guys, this 2 in here, let me highlight it down. This 2 in here, it doesn't like have any square root, right? So it's still like beautiful. We have no like problem with it. But this 2 in here, let me highlight it in orange, is trapped under the square root. That's why we'll have to make more copies of them for top and bottom to cancel that square root. Okay, and after this, we're going to multiply top and bottom together. The 3 is outside of the square root. The 2 is inside. So on the top part, we're going to get 3 square root of 2. On the bottom part, the 2 outside, we're going to keep it outside, times square root of 2 times square root of 2. We have square root of 4, which is 2. So that's another 2. So at the end, we're going to get 3 square root of 2 divided by 4. Okay. Now, once again, in the test, in the assessment, I'm okay with this answer, but I would prefer this answer. That's why I box it, because it looks like really beautiful to me. Okay, those 2 are the easy ones, right? Because we just flip them. There's no big deal. Now, tangent and cotangent. Okay, here comes some like fancy math work. Tangent here, we have the formula for it. Tangent equals to sine divided by cosine. We have sine, we have cosine, so let's divide them out. We're gonna get 1/3 for sine divided by 2 square root of 2 divided by 3. Okay, so this one is like back to algebra. If you don't remember how to divide 2 fractions, I'm gonna give you guys a rule. It calls keep, flip, multiply. It means that we keep the first fraction, we flip the second fraction. Okay, that's a square root, that's a 2, and then we multiply them. Okay, so this one, keep, flip, multiply. Okay, before we multiply top to top, bottom to bottom, let's try to cancel as much as we can. And this is like cross cancel. Okay, lots of you guys might have the question, why don't we use cross multiplication like the last time when we try to convert from radians to like degrees, because we have like 2 fractions in there. I'm gonna tell you guys in the next second why we don't do that. Okay, so now let's talk about this multiplication first. So instead of like multiply straight, let's cancel the 3's out first. So then this one, 3 goes in 3 one time and 3 goes into 3 once time, right? So then on top we have 1 times 1, which is 1, and on the bottom we have 1 times 2 square root of 2. So then this in here, if you do the same process as we did in here, we're gonna get something like square root of 2 divided by 4. Okay, if you don't trust me, you can do it, but you can check it out by yourself. Okay, and if there's anything, just let me know. Alright, now let me explain why we're not going to use cross multiplication in here. Okay, so first of all, let me point out 2 things. 1/3 equals to, say, 3 divided by x. This is different compared to 1/3 times 3 divided by x. Okay? For the first one, we can do cross multiplication to get x equals to 9. This is legal because we have the equation. We have the equal sign between. But for the second one, unfortunately, we don't have the equal sign between. We have multiplication in between. And that multiplication tells us to multiply top with top, bottom with bottom. And if you forget to cancel before you multiply them, it's all good. We can cancel them afterward to get 1 divided by x. Okay? So, okay, some people might wonder why this answer is not x, because like this 3 is kept like gone. I'm gonna tell you one thing. This x in here is on the bottom, like from the beginning, right? So it cannot be like hanging in there. That's first. Secondly, 3 cancel by 3, we're gonna get 1 in there and 1 in here. This 3 in here is not completely gone. It's being reduced to 1, but it's not like turned to air. Okay, so keep that in mind. It's just like algebra mistake that I don't want you guys to get confused in the homework or the test. So those are something you have to watch out for. Okay. Now let me get rid of these so that I get some space. All right, that should be enough space. All right, let's. Oh yeah, we still have one more thing. Okay, so tension in here, it equals to square root of 2 divided by 4. This answer is from here. Okay, for cotension, we're gonna flip whatever we get from tension. So this could be 4 divided by square root of 2, but I told you guys, like, I'm a lazy person, so instead of flipping that, I'm gonna flip this answer right here, like the one right before the final answer. So I'm gonna have something like 2 square root of 2 divided by 1, which is 2 square root of 2. This is the final answer for cotension, and this is the answer for tension, and this is the answer for cosecant. Okay, and here's your turn. This example right here. Okay, part B. Find the exact value of trigonometric expression using identities. Alright, so first of all, let me clear out some information in here. Okay, so we have this, and right after that, we know this, there's a square. There's a 2 on the top right of secant and tension. If you look in this table in here, the only place where you can find a square is the Pythagorean identities. Only these 3 formulas contain the squares. Okay, and now our job is to find the one with secant and tension, right? The first one is talking about sine, cosine. The last one is talking about cotension and cosecant. The only useful one in here is tension and secant. Okay, so our job is to manage to the point, well, to manage this become that. How can we do that? Secant, we have secant, but we don't have minus tension square, right? So let's minus tension square from both sides. That means we're gonna get minus tension square, and this is a bad, like, illegal writing, because on a trig function must be attached to an angle. Okay, so please make sure to attach an angle to it. 28 in here in degrees. I'm not gonna write degrees because it's gonna look messier, but in a test, please write degrees, okay? Please don't drop out any units. Alright, so if you do it like this, then on the left hand side, the 2 tension square will cancel out with each other. On the right hand side, this will look exactly like what we have in here. There. And then the answer is 1, because 1 is the only thing that's left on the left hand side. Okay, this is one way to do it. There's another way to do it. We know that secant square equals to tension square plus 1, right? So let's replace this secant square by tangent square of 28 degrees plus 1. Okay, and then let's rewrite this minus tangent square of 28 out here. And now this cancels out with that, and the final answer is again 1. Okay, so you have two ways to do this thing. One is to manage the formula of this one to become whatever the problem looks like. The second way is by using substitution. Whichever way you feel more comfortable with, do it. Okay, and if you wonder why in the formula in here they use theta, in our example we use 28 and it's still legal, it's still something like doable for us. Well, theta in here is meant any angle, okay, as long as the angles in tangent and secant are the same. Like for example, like this is 20 and this is 28, we can use this formula right here. Okay, another scenario could be something like, I could give you guys something like secant of, I don't know, like 10 degrees, and then minus tangent of tangent square of 10 degrees. The answer will be 1. Why? Because we're going to follow the same procedure. We're going to do the same formula. We're going to do the same thing as we did earlier. Because theta in here could be like any angle. It's just probably saying like an angle, an acute angle to be more precise for this section. Okay. A big no-no in here is that if I give you a problem, say secant square of 28 degrees minus tangent square of 10 degrees, this would not be applicable to this formula in here. Why? Because the angle that we have right here is not the same as the angle that we have right here. For this class, I'm not going to give you like this. I'm not going to give you something like this in the assessment, at least not for 7.2. Okay, so you don't have to worry about this case. If you were to see it, you can tell me there's a typo in the test and I'll fix it. Okay, but like for sure I'm not going to give you something random like this. The angles must be the same. Okay, we're going to learn something about like double angle, half angle, and some relationship between the two angles in these half like positions, but later, not in 7.2. So for 7.2, the angles must be the same if you use Pythagorean identities. Okay? So let me put a green star on your turn. So this is your turn, and again I took out a green star, but this one too. Okay, third objective. Find the values of the remaining trigonometric functions given the value of one of them and that the angle theta is acute. So if you recall like this picture from example 1, you will see that it looks exactly like the picture in example 1, right? Like we changed the data, we changed the position of theta, and we changed the triangle. But the way to do it is the same way, okay? You actually don't miss this piece of information because you can get it from the picture. If theta is this angle right here, opposite to it, we have square root of 3. This is opposite. 4 in here is opposite to the right angle, so it must be the hypotenuse. And the only like leftover side has to be adjacent. Okay, so method 1 is what we did in example 1. I call it definition because what you do is you use SOHCAHTOA. And remember, SOHCAHTOA are actually the definition for sine, cosine, and tangent. Okay, so if I ever ask you, what is the definition of sine? You're going to tell me the definition of sine is opposite divided by hypotenuse. Okay? Right, so just like example 1, first of all, we have to find the third missing sine. And in here, we're looking for adjacent. We're not looking for hypotenuse anymore, right? So it's not going to be like something plus something. But if you recall, I show you guys like a trick to replace with the ABC system in the Pythagorean theorem. You guys can remember adjacent square plus opposite square equals to hypotenuse square. Okay, let me write it in here. Adjacent, we have nothing, so let's leave it as adjacent square. Opposite, we have square root of 3. We square it up and we got 3. Hypotenuse is 4. 4 squared is 16. And then we're going to do minus 3 from both sides. And then we have a squared equals to 16 minus 3, that should be 13. And lastly, I told you guys this is not the answer because it's only a square. We have to get rid of the square by taking the square root of both sides. So then this is A. A in here, adjacent in here, equals to square root of 13. Okay, now that we have like all three sides, I'm gonna like do it really quickly on this one because we did it already on example 1. And before we get to like the 6 answers in here, you guys might wonder what is the blank in here. This one in here is like left for the definition of sine, which is opposite divided by hypotenuse. Okay, so then sine here, opposite divided by hypotenuse. Opposite we have square root of 3, hypotenuse we have 4. Cosine is adjacent, square root of 13 divided by hypotenuse 4. Cotangent we have opposite, which is square root of 3 divided by adjacent, square root of 13. We're going to multiply both top and bottom by square root of 13. 13 times 3, I'm going to get 39, and on the bottom I got 13. Okay, that's my ugly 13. Alright, we're going to flip it on the second column to get 4. This is my 4 over square root of 3 in here. If you rationalize it, you're going to get 4 square root of 3 over 3. Secant, it is 4 square root of 13 out of 13. And lastly, we have square root of 39 divided by 3. Okay, please double check my answer, and if any of these are wrong, let me know. Okay, or if you have like any questions on any of these, I should say, yeah, just let me know, hit me up. All right, that's the first method. We call it the definition method. Second method, identities method. Okay, this one like it requires more technique in algebra, I believe. But well, we'll be cool with it as long as you have like the table of the identity style. We're cool with it. All right. So we're given that sine equals to the square root of 3 over 4. Let me write that here. So right after that, across it, we know that cosecant is a flip of it, which is 4 divided by square root of 3, and then we rationalize it, and we're gonna get 4 square root of 3 over 3. That's the easy part. Now the other part, right? So this one, let me scroll out of the table. This table in here, the table of the identities, you will have like a lot of formulas in here, and then you can find like the next one as long as you want to. Like try to find the one that has sine there, because the only information that we know for now is sine, right? So from sine, where can we go? What is the next thing we can find, right? Let me highlight the one with sine first so that you guys see. Okay, this one has sine in there. These has sine in there. And then this one has sine there. Okay. Let's see. Cosecant, the very first formula. This one we already use it up because we already flip it to find cosecant. So that's like out of the way. We don't have to worry about it. The next two formula for tangent and cotangent, we don't have cosine, right? So this is like out of the way either. I mean, this is out of the way too because we don't have cosine, so we cannot use it for tangent or cotangent. So the only option that we have in here is this. Sine squared plus cosine squared equals 1. Okay, so now let me scroll back in the page. What are we doing? Alright, so by Pythagorean identities, okay, shortcut, I'm just going to do like sine squared plus cos squared equals to 1. Because I know for a fact that these sine and cosine have the same angle. That's why I'm just going to write S and C for shortcut for sine and cosine, okay? Like, if you want to do it for homework, that's fine, but, like, this is a bad habit. I'm trying to get rid of it, but, you know, yeah. It takes time. Alright, so we know the sine here, it is square root of 3 over 4. If we square it, the top will be 3 and the bottom will be 16. Okay, and then we plus cosine squared equals to 1. Let me bring it down here. So if we subtract, if we minus both sides by 3 over 16, we're going to get c squared equals to 1 minus 3 over 16. And if you guys remember this, 1 is actually 16 over 16. We need the common denominator. So then c squared in here equals to 13 divided by 16. And again, this is not c because it's c squared. If we want to get c, we have to free it out from the square. So then we're going to do the square root of it. Okay, and then this in here will give us square root of 13 on top, and square root of 16, we know that is 4. Here is a 4. I try to write it in the corner, and it doesn't look like it. Listen. Okay, there we go. 4. So, C in here is 4. C in here for cosine. So, this in here is that. Cosine equals the square root of 13 over 4. And right across from it, we're going to flip it to get 4 divided by square root of 13. And then we're going to get something like 4 square root of 13 divided by 13 if you rationalize it. Lastly, we're going to get tangent. And if you remember from like one of the options that we crossed out earlier, tangent equals to sine divided by cosine. So let's divide them out. We're going to do square root of 3 divided by 4 divided by square root of 13 divided by 4. And we're going to do key flip multiply because we're dividing two fractions. So square root of 3 over 4 is still square root of 3 over 4. The second fraction, we flip them. And then we, okay, this is my 3, but it doesn't look like a 3. Let me write more properly. There we go. And then we multiply them. So the 4's are cancel, and then we got square root of 3 divided by square root of 13, and then we rationalize it to get square root of 39 divided by 13. This is tangent. So we have square root of 39 divided by 13. For cotangent, I mean, I can flip this one, but I'm going to flip that one, okay? So to get square root of 13 divided by 3, and if you rationalize it, it's going to be square root of 39 divided by 3. Okay, if I do it too fast, or if you have any question on this one, please let me know, okay? And because I'm showing you guys two methods, so the answers in here, they should look the same, right? If you want to check, let me circle them in blue. These answers in here are actually the same thing that we have in here for the system. Okay, we have sine, the same. This one, flip it. And then tangent and cotangent, we just got them. And then this one is square root of 13 divided by 4. Flip them, we get the same answer. So all 6 of them look the same, right? So here's your turn. Here's the start. You have to do both method 1 and method 2, okay? Wait, okay, so the very last objective of today. Okay, it's a blank space. Alright. Okay, 4. Use the complementary angle theorem. Alright, so this one is like, it's easy. Well, it's always easy if you understand it, right? So, let's see. What does it mean by complementary? Complementary is the word we use for two angles if they add up to 90. Okay, so in here I just put it in short term if the sum is a right angle, which is like 90 degrees. Okay, so you can have something like 30 and 60. These two are complementary to each other. Why? Because they add up to 90. If I'm asking you what is the complementary angle to 10, well, you're gonna tell me it's 80. Okay, and another example is like, if I ask you what is the complementary angle for 80, you're gonna tell me it's 10. Okay, it's just like simply add up to 10 to 90. Like the two angles must add up to 90, or how to get the other angle is like you do 90 minus the first angle. Okay, so remember the word complementary. Okay, and here's the big theorem, complementary angle theorem, or I call it CAT. Okay, this one you're gonna see it in a test, so don't be surprised if you see cat. It doesn't mean like cat and dog. It's just like complementary angle theorem. Okay? It says that cofunctions of complementary angles are equal. Alright, let's break it down here. We know what complementary angles are. They are just two angles that add up to 90, right? But what does it mean by cofunction? Cofunction in here, we have three pairs of cofunctions. Psi is a cofunction of cosine. Cosine is a cofunction of sine. Tangent is the cofunction of cotangent. And cotangent is the cofunction of tangent. Secant is a cofunction of cosecant. And cosecant is the cofunction of secant. If you wonder why each of the c functions have the word co, it's because they are cofunctions of the non-c functions. Okay, and my tips to remember this, they go by names, right? Like sine, cosine, secant and cosecant, tangent and cotangent. Okay, very easy to remember. But make sure you know what it means by cofunction. Okay, they just like pair up. Cofunction, there's no real like definition for them. I'm gonna like tell you how useful cofunctions are in a moment for complementary angle theorems, but for now just remember cofunctions, they just mean the three pairs. Okay, like the three pairs that have the names match up to each other. Alright, so right now, like this system that you see right here are easy because we're doing them in degrees. So then you know that like 60 plus 30 is 90, and then 10 plus 80 is 90 degrees, right? But we learned about radians system already, so let's take it to the next level. How about having it in radians? These will be a little bit like harder to do it, but just remember one thing: pi radian is 180 degrees, right? So whenever you see pi, it means 180 degrees. Okay, so pi over 6 in here, it means 180 divided by 6, which is 30 degrees. And then pi divided by 3 in here, it means 180 divided by 3, which is 60 degrees. So they mean the same thing to what we had earlier for the two angles that add up to 90 degrees. You just have to do a little bit more work in the sense that you have to convert them from radians to degrees to add them up. Or if you're strong with algebra, with fraction, you can do pi over 6 plus pi over 3. And in here, if you want a common denominator, you're going to multiply the second fraction by 2. So then this one will be 6, and we're going to get like 3 pi over 6, which is pi over 2. And if you remember pi over 2, it is 90 degrees. So they mean the same thing, okay? But it's just like different representations, okay? Same thing with this one. Pi over 4 is 45 degrees. Another pi over 4 is another 45 degrees. 45 plus 45, we have 90 degrees. This one, pi over 5, means 180 divided by 5, which is, let me calculate it out, 180 divided by 5 is 36 degrees. Okay, and then the other angle, 3 pi divided by 10. 3 times 180 divided by 10, we have 144. Right? Oh no, 3 pi divided by 10, we have 54. Okay, 36 and 54. They add up to 90. If you don't trust me, you can check these up on your own as well. So they just means the same thing as we did before, but again, it looks harder a little bit because you have to get used to the pi system, okay? We have to get used to the radian system. All right, so that's about the angle. Now let's talk about a cofunction. Okay, let me get more space in here. Okay, cofunction. Sine pair up with cosine, tangent pair up with cotangent, secant pair up with cosecant. So this theorem tells us two things. In order to qualify this theorem, the angles have to match up and the function have to match up. Okay, sine must go with cosine. Okay, so like to make it easier to look at, here, let me write it down here real quick. Sine of 30 degrees equals to cosine of 60 degrees. There are two things in here for us to notice. The angles in here, they add up to 90 degrees, and the functions in here, they co-function of each other. Okay? If you don't qualify one of the requirement, it's wrong. It's not going to be equal to each other. For example, if you write like sine of 30 degrees equals to, I don't know, like tangent of 60 degrees, well, you argue that I have the two angles that add up to 90, but this is still wrong. Okay? This is still not correct. Why? Because the co-functions are not like the right one. Sine doesn't pair up with tangent. Okay? And another scenario is when you have like sine of, I don't know, like 30 degrees, and then you set it equals to cosine of 10 degrees. You said that this is true because I have sine here and cosine and cosine are co-functions. Well, this is again not true. Why? Because the angles in here, they don't add up to 90. Okay, so two requirements that you have to follow. First of all, they have to qualify the co-function things. Second of all, they have to be complementary. Okay, so this is like a table that says what I just say right now, but then just, you know, like math symbols. So this one in here, the very first box, it tells you that sine of theta equals to cosine of 90 minus theta. For example, if theta in here is 30, sine of 30 equals to cosine of 90 minus 30, which is 60. Okay, and then similarly, like the same process will happen for the other boxes. All right, let's talk about the last example. Use the complementary angle theorem to find the exact value of each expression. How can we do this? First of all, we need the same angle if you want to add up the first term, or if you want to subtract the first term and the second term. If you want to combine the terms together, they must have the same angle. Okay, it's not gonna work. It's like you adding like a candy with a rock. It doesn't work, you know. So first of all, how can we simplify the system? We know that this is 40, so let's convert this into something with 40. On the bottom, we have sine of 40, which is good because it's in 40 already. But on the top part, we have sine of 50. This is not 40, unfortunately, right? So we have to find a way to convert from 50 to 40. Well, fortunately, 40 plus 50 equals to 90, right? So that's one of the requirements of the right? Like of the complementary angle theorem. They add up to 90. That's great. So let's write an angle 40 in here. All right, we have the angle already. Now let's talk about a function. What should we put in front of 40? Should we put sine, cosine, tangent, cosecant, secant, or cotangent? Well, the second requirement is that we have to do co-functions, right? So what goes with sine, we have cosine, right? Just by the names again. Really easy to remember. Co-functions, they go by the names. So we know that sine of 50 degrees equals to cosine of 40 degrees. So this in here will become cotangent of 40 minus cosine of 40 divided by sine of 40. And if you remember this from the table of the identities, cosine divided by sine, it gives us cotangent of 40. And let me rewrite the first cotangent. Okay, so the cotangent in red is just like I rewrite from the last line. The cotangent in orange is like from cosine divided by sine. It's like one of the identity in the table. This is the quotient identity. Okay, so these, they canceled out. Oh, sorry for this. Okay, this we canceled out, cosine with cosine, and it equals to 0. So 0 is the final answer for this one. Okay, and then let me put a green star on this one. This is your turn. You have to do this one. Okay, so if you have any question on any of these, let me know. Just email me. Just contact me. Okay, thank you. Bye bye.